In this video, I will show you how to put software tools together so you can start using SQLite on Raspberry Pi efficiently. First, I will show you how to install SQLite on Raspberry Pi. Then to create an SQLite database to work on. Then I will install SQLite extension on Visual Studio Code. With SQLite extension, you will have a database manager with Graphical User Interface. I use SQLite extension to create table and perform some operations on the table, such as insert rows into the table and retrieve rows from the table. Finally, I will show you a Python program to retrieve records from SQLite table and display the results on the screen. Here is the system configuration to begin with. I have a Raspberry Pi with Raspbian, and the additional software required are Visual Studio Code, Python extension for Visual Studio Code, and GUI 0 library for Python. If you need help with software installation, please watch my earlier video. Here are some terminal commands to begin using SQLite. I will not be using terminal commands to manage the objects in SQLite databases. Instead, I will be using Visual Studio Code as database manager. The only SQLite command I will be using is to create an empty database. If you have not updated your system for a while, please do it now. Enter the command to install SQLite. Now validate the installation and check the version. The version installed is 3.27.2. Let me create a folder named Database to keep the SQLite databases. Now I will create a database named studentscore.db. I have just created an empty database. The rest of the work on the database will be done with Visual Studio Code. Now I will install SQLite extension for Visual Studio Code. Launch Visual Studio Code. Click on Extension icon. Type SQLite at search box. I will be using the SQLite extension by Alex CVZZ. There are other extensions that are equally capable. Feel free to try them. Click on Install button to install. The installation won't take long. In the rest of the video, I will be working on database studentscore.db. I will create a table named Score to keep track of the test score of students. The score table has 3 columns: class number, student number, and test score. The class number is a 3-digit number. Student number is a 4-digit number. And the test score is a number between 60 and 100. I am ready to work on the database. Click on the Explorer icon. Click on Open Folder button. Select the folder Database, which was created earlier. You can see the empty database is available in this folder. First, I will create a table named Score. Click on New File icon. I will name the file createTableScore.SQL. This is the SQL statement for creating table score. The table has 3 columns: class number, student number, and test score. I have defined a primary key for the table, which is the combination of class number and student number. I have also defined 2 indexes on the table. To run the SQL statement, right-click on the source code area. Select Run Query. If this is the first time you run the file, you will be asked to choose the database to use. I will select StudentScore.db from the list. Look at the SQLite panel. This means the command is successful. It is also possible to run part of the query. Let's say I want to drop the table. Highlight the part of the code I want to run. Right-click and select Run Selected Query. The table is dropped. Let me create the table again, this time without the index. And create the indexes again. Now I'm ready to insert some rows into the table. I am inserting 240 rows. At the end, I am checking the number of rows in the table. Look at the SQLite panel. You can see there are 240 rows in the table now. Run the query again. I get error because the table has primary key defined. Duplicate keys are not allowed. Let me run some queries against the table. A little bit of warning here. Do not attempt to select too many rows from the table. Use limit keyword to control the number of rows returned if possible. The first query is to select all columns from the table. I am selecting only the first 100 rows. The results take 2 pages to display. Use the arrow key to navigate between pages. The next query is to select average score by each student. There are 40 students. Delete and update query can be done in the same way. SQLite extension has built-in export function. There are several export formats available. You can export either with HTML format, JSON format, or CSV format. Let me show you how to export with CSV format. Click on the Export CSV icon. I will name the output studentaverage.txt. Now let's examine the content of the exported file. Double-click and double-click. You can see there is a headline with column names. That's all for SQLite extension. In this Python program, I will show you how to access SQLite database. Let me run the program first. When I enter a student number and click on Show Score button, the test score related to this student will be displayed on the screen. If the student number is incorrect, an error message will be displayed. Now let me walk you through the source code. Let's have a look at the GUI section first. I'm using grid layout to control the placement of the widget on the screen. A text object to guide the user for input. A text box object for user to enter the student number. A push button object to trigger the action. Box score is a placeholder for student scores. It is initially empty. Notice again it is a grid layout. That is a grid within grid. An exit button to close the screen. Finally, a text object to display the program status. Next, have a look at the SQL statement. Instead of using an asterisk, I have specified the column names to retrieve, so I can control the sequence of the columns returned. And I'm using a question mark for student number, which means a parameter will be passed. Now let's have a look at the function that responds to the show score request. First, I destroy and recreate the box score object to clear out whatever was on the screen. Notice again, the box object is using grid layout. Then I check if the student number is a valid numeric number. If not, an error message is displayed, then exit from the function. This is the part of the program that retrieves information from the database. A connection is established with the database. Then a cursor is defined to access the database. Then the SQL statement defined earlier gets executed with the student number passed as parameter. The fetchAll function will retrieve all rows from the database as specified by the SQL statement. Then I close the connection. In this last section, if the rows are empty, I display an error message. If there are rows returned, I display a heading for the results. Then for rows returned, I put them one by one in the box score object. Notice how the grid is used to place the heading and content of rows. That's all for the source code. Let me run it again. That's it for this video. See you next time.